All right, let's talk about unboxing something truly special. I mean, this is a package that's traveled millions of miles, and it's literally billions of years old. We're talking about the sample from the asteroid Bennu, a cosmic message in a bottle sent from the very beginning of our solar system.
So that's really the big question, isn't it? What can this handful of dust actually tell us? You have to think of it like a giant cosmic puzzle. Every single grain could be a piece that tells us how planets formed, where our oceans came from, and yeah, maybe even how life itself got started. And right now, scientists are just starting to put those pieces together.
I mean, this stuff is basically the oldest, most pristine time capsule you could ever imagine. We're talking about carbon-rich material that has been perfectly preserved in the vacuum of space for 4.5 billion years. It has never been touched by Earth's atmosphere. This is it, a direct sample of the raw ingredients that built all the planets, including ours. All right, so how in the world did they pull this off? Let's get into it because grabbing this sample was, and I'm not exaggerating, an absolutely epic undertaking. Think of it like a 7-year-long interplanetary heist to snatch a piece of an asteroid and bring it all the way home. So the mission was called OSIRIS-REx, and it was just a masterclass in patience and precision. It took years just to get to Bennu. Once it was there, it mapped the whole thing out. And then in 2020, it pulled off this incredible touch-and-go move. It was basically a cosmic high five. The spacecraft just tapped the surface and blasted it with nitrogen gas, which kicked up a bunch of dust and rock right into a collection head. And then another long trip home, leading to the grand finale on September 24th, 2023, when it dropped that sample capsule to blaze through our atmosphere and land perfectly in the Utah desert. And, once it landed, the clock was ticking. The level of care they took was just mind-blowing. A recovery team was there by helicopter in under 20 minutes to make sure nothing from Earth contaminated it. They airlifted it to a special clean room, and here's the really clever part. They did what's called a nitrogen purge. They basically flushed the whole container with pure nitrogen to push out any of our pesky Earth air that might have snuck in. This kept the sample in its pure alien state, completely untouched by our world. Okay, so the sample is safe, it's secure, and it's on its way to NASA's Johnson Space Center. This is where the next chapter begins. This is where the real fun starts, the official unboxing of a 4.5 billion-year-old artifact. And get this, right away, they get a surprise. As soon as they opened the main canister, they saw all this dark powder and little sand-sized particles coating the inside. It turns out the collection went so well that the collector head was literally overflowing and couldn't close all the way, so some of the samples spilled out inside the container. And this was great news. It was bonus material that scientists could start analyzing right away, even before they got the main part open. But of course, it couldn't all be that easy. There was a little bit of drama. The main collector head is called the TEGSAM, was sealed shut with 35 fasteners. Well, 33 of them came up just fine. But 2 of them? Nope, they just would not budge. The standard tools they had just weren't cutting it. So the team had to actually pause the whole operation to design and build brand new, custom tools just to get these 2 stubborn fasteners off without risking the sample. So you might be thinking, oh no, what a disaster with those fasteners. Did it even matter? Well, not one bit. Turns out, even with just that bonus dust that spilled out, they'd already collected over 70 grams of material. The mission's goal was 60 grams, so they'd already won. The final total came in at a whopping 121.6 grams, more than double what they were hoping for. Just an incredible success. All right, so they've got the sample, it's safely in the lab, and now the scientific interrogation begins. This is the whole point of the mission, right? What secrets is this ancient dust finally going to confess? And let me tell you, the initial findings were absolutely fascinating. So the first thing they had to do was check their work. Remember, the OSIRIS-REx spacecraft had spent years studying Bennu from orbit, using special instruments to guess what it was made of. The big question was, did the real stuff, the sample they had in their hands, actually match what they saw from millions of miles away? And the answer was a huge, resounding yes. It was a perfect match. Everything they predicted they'd find was there. You've got these hydrated minerals that hold water, you've got magnetite, organic compounds, carbonates, check, check, and check. It was all there. And that's a massive win for science because it proves just how good we've gotten at figuring out what distant asteroids are made of without even having to go there. But let's be real. You don't spend 7 years and billions of dollars just to confirm what you already think you know. The real prize is finding the stuff you didn't expect, the surprises. And oh boy, this is where the story gets really, really good. First up, they found something called presolar grains. And I want you to really let this sink in. This is actual, literal stardust. Tiny, microscopic grains of minerals that are older than our own sun. They formed in the atmospheres of stars that died long before our solar system was even a thing. They got blown out into the galaxy, and eventually they got mixed into the cloud of gas and dust that created our sun and all the planets. We are literally holding pieces of other long-dead stars in a lab right now. How cool is that? Then there was this other unexpected bit of chemistry. They found this weird kind of phosphate packed with magnesium and sodium. Now that was a surprise on its own, but what was really wild is that it looked familiar. It's really similar to phosphate materials that the Cassini mission found in the water plumes shooting out of Enceladus, Saturn's icy ocean moon. It's a clue that maybe there's a kind of shared chemistry happening across huge distances in our solar system. So you add it all up, right? You've got water locked in the minerals, you've got complex organic compounds, you've got this exotic chemistry, and it all points to the biggest reveal of them all. It's powerful, fresh evidence for a theory that's been gaining steam for years, that the basic ingredients for life didn't actually start here on Earth. They were delivered by asteroids. And the smoking gun? The key ingredient they found? Tryptophan. Yep, that's one of the 20 essential amino acids. The fundamental building blocks of all life as we know it. You've probably heard of it from that old myth about Thanksgiving turkey making you sleepy. Well, forget the turkey. We now know for a fact that this crucial building block for life exists on an ancient asteroid, which just makes the case even stronger that Earth got a very special delivery a few billion years ago. Okay, so Bennu has given us this incredible recipe for life. But here's the twist. This asteroid has two faces. It embodies this profound duality. It represents both creation and potential destruction. So on the one hand, you have asteroids like Bennu acting as a cosmic Uber Eats, delivering the starter kit for life all over the solar system. But on the other hand, Bennu is also classified as a near-Earth object, which means it has a small but definitely not zero chance of one day hitting our planet. It's a life giver and a potential world ender, both a possible ancestor and a future threat. And if you want to understand the disaster side of that equation, you really only need one number: 1,200 megatons. That is the estimated raw energy that would be unleashed if an asteroid the size of Bennu ever hit Earth. Now, to put that number into perspective, because it's hard to even wrap your head around, the Tunguska event back in 1908 that flattened a huge chunk of Siberian forest, that was about 5 megatons. The Tsar Bomba, the biggest nuclear bomb ever tested, that was 54 megatons. A Bennu impact would be over 20 times more powerful than the biggest bomb humans have ever created. It's just an almost incomprehensible amount of destructive energy. And that's really the powerful, maybe even haunting thought we're left with. This little pile of black dust that we so carefully brought back from millions of miles away, it contains the chemical signature of our own origin story. It helps answer that huge question: where did we come from? But in the same breath, it forces us to ask another, much scarier question. Does the very thing that represents our beginning also hold a clue to our potential end? It's a question that really puts our place in this beautiful and sometimes violent cosmos into perspective.